Hi everyone, in today's video we are going to talk about the embedded project for this semester. Our project is called in Molook. Most of the fans used to operate with constant speed regardless the temperature and humidity. According to human interaction, that if you set it on for example speed 3, it will operate regardless of the temperature. So we thought about implementing a smart fan that operates according to the temperature it's found to be in. So for example, it operates at temperature 25 Celsius, different than that when it's found to be in 30 Celsius, and so on. So my colleague Kareem Yasser and me, Ahmed Habib, are going to talk about the hardware part, and our friend Ahmed Hatem is going to talk about the software part. So let's first talk about the components part. We use the DC fan and a DC battery, an Arduino, and a DHT11 sensor. This is a temperature and humidity sensor. And we use the DC driver to convert the current from the Arduino to the fan. And we use the LCD to display our desired output.
Okay, my name is Kareem Yasser. I was responsible for the hardware part. Okay, speaking about the hardware part, it was quite easy. We used the Arduino to connect the LCD. The LCD used a library called Liquid Crystal. It's a predefined library connecting the LCD with these pins in the Arduino. Then we made a common ground and a common 5 volt here from the Arduino till the breadboard. We also connected the sensor. The sensor consisted of 3 pins, a data pin which was connected to the 5 volt, and another 2 pins, one as a ground and the other as a predefined pin in the Arduino to be used in the code. Speaking about the edge bridge, its function was to convert the 20 milliampere generated by the Arduino to a 200 milliampere by the fan. So as not to burn the fan, we used this edge bridge. The edge bridge consists of 3 ports from here. The first one as an enable to enable the fan to start rotating. Another 2 pins, input 1 and input 2, either 0 or 1 to a clockwise direction of the rotation of the fan, or 1, 0 to anti-clockwise direction of the fan. We used also the battery, positive and negative edge, in order to supply volt to be able to rotate the fan.
I am Ahmed Hatem. I'm going to talk about our code. Our code is simple, but it's always efficient. First of all, we downloaded the DHT sensor library and we included it. Then we included the liquid crystal library. So we have set the LCD input pins from here. We defined the DHT sensor. Then our code is consisting of 2 methods. First of all, we used to set up our project. So at the beginning we used pin 8 and 13 as output. These are responsible for the fan. Pin 8 and 13 are responsible for the direction of the fan, whether it's anti-clockwise or it's clockwise. Then we set up the LCD. We start by printing our project's name, then our team's name, then embedded project. We use delays between them so that they actually have 2 seconds to appear between each other. Then comes the loop method, which is actually the main method for our project. And we first start by setting up pin 12, that will be the input from the temperature sensor, meaning that the temperature will be determined from the sensor and then will be transmitted to us by this pin. Then we should delay the code for a small amount of time so that the sensor gets set it up. Then we determine the temperature from the method get temperature from the DHT library. Then we print temperature on the screen, and we print the actual temperature. After that, we are checking for the temperature. So when the temperature is less than 15, we turn off the fan. If it's between 15 and 20, we set pin 9, which is the enable of the fan, to be 102. 102 is the 40% of the speed of the fan, which is between 0 and 255. Then we write high and low to the pins 8 and 13, so it can tell it the direction that we will move on. If it's between 20 and 25, we will make the speed 153, which is 60%. If it's between 25 and 30, we'll make the speed 204, which is 80%. Then it's more than 30 or equal 30, the fan will run with its full speed.
And now it's time to show you our final project.